welcome back. Today's lesson is going to seem very similar to yesterday's lesson in that the idea is today we're going to prove lines parallel. So here are the 5 postulates and theorems. They almost look exactly like yesterday, except these are in reverse. They're the converse. So basically, if you wrote down all the theorems and postulates from yesterday, these are just going in reverse. So just to kind of remind you of what we did yesterday, we said for the corresponding angles postulate, said that if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. Well, today, they're saying if 2 lines are cut by a transversal, so if the corresponding angles are congruent, then the lines are parallel. So it's literally in the exact opposite order here. We're going in reverse. So you'll use the converse if you're proving lines are parallel. You'll use the original version if you already know your lines are parallel. So let's jump right into it. Let's prove one of these theorems just like we did the other day. And again, I'll point out the differences. Today, we've got angles that are congruent. We're proving lines are parallel. Yesterday, these were flip-flopped. So for this, I'll start off with your first statement. Angle 1 is congruent to angle 2. That was given. And then you could come up with some other information from the picture, such as angle 1 is congruent to angle 3. That would be because they're vertical angles. That would be the vertical angles theorem. And then if you said 1 is congruent to 2 and 1 is congruent to 3, let's cut out the middleman and say angle 2 is congruent to angle 3. That would be through your transitive property. Remember that you can't use substitution property there because there is no substitution property for congruence, so that would have to be transitive property. Another common mistake people are going to make here is they're going to say 2 is congruent to 3 because they're corresponding angles. And that is why it was so important to understand yesterday's lesson, because you can only say these 2 angles are congruent because they're corresponding if they're on parallel lines. And right now, I don't know if these lines are parallel. We're trying to prove that. So it has to be transitive property there. Which in step 4, we can say L is parallel to M because 2 and 3 are corresponding angles. We just said they are congruent, so that would be the converse of corresponding angles postulate. Meaning we have 2 corresponding angles that are congruent. In that case, they must be on parallel lines, so L is parallel to M. And again, if we were to prove all 4 of those theorems, they would all look roughly the same. So we're just going to do one. By the way, in the future, you won't have to do all this. In the future, you'll be able to go from step 1 all the way to step 4, and you'll just be able to say converse of alternate exterior angles theorem. Because in the future, if you say, hey, 1 is congruent to 2, well, if your alternate exterior angles are congruent, they must be on parallel lines, and you'll be able to go straight from 1 to step 4. So moving on, what your homework looks like. Most of it looks like this. It says in the photo, angle 2 is congruent to angle 6. I've already marked that here with arc marks. And it says what theorem or postulate can you use to show that line J and K are parallel? Well, they must be parallel because their corresponding angles are congruent. So that would be the converse of corresponding angles postulate, just like we used in that last proof. Of course, if I gave you other examples, like if I told you 4 and 5 were supplementary, you would say that's the converse of same side interior angles. One more property to add to your ever-growing toolbox would be the transitive property of parallel lines. This works just like transitive property we've used in the past. If A is parallel to B and B is parallel to C, well then we'll cut out the middleman. A must be parallel to C. So it's just kind of the same transitive property we've been using. This is just for parallel lines this time. We're going to finish with a couple practice proofs just to kind of keep you going on that. Starting with this one, number 1, I'm going to start off with L is parallel to M because that was given to us. Now, you could put both your givens in the same statement there, but since they're talking about 2 different things, I'm going to separate them out. In fact, as soon as I hear that L is parallel to M, I'm looking over there at my picture, and because I know those are parallel lines, indicated by the arrows, because I know those are parallel lines, I could also say for number 2 that angle 1 is congruent to angle 2 because they are corresponding angles. So that would be your corresponding angles postulate. Not the converse there, because I already know those lines are parallel. So that's going to be your original corresponding angles postulate. That's kind of all the information I can take from that first given. So now I'm going to move on to my second piece of given, which is that angle 1 is congruent to angle 3. And when I look there and I say, okay, well, angle 1 is congruent to angle 3, I just got done saying angle 1 was congruent to angle 2. Let's synthesize that information, or in other words, put it together. Angle 2 is congruent to angle 3. That would, again, would be your transitive property. And if angle 2 is congruent to angle 3, those are your alternate exterior angles. So like I said, you don't have to do all those steps. You can just cut to, hey, line R must be parallel to line P because of the converse of alternate exterior angles theorem. And again, we're using a converse there because we're proving lines parallel. Moving on, last one, last proof. You can try this on your own. There's actually multiple ways to do this proof. I'm going to do it the short version, or the most efficient version. And that is, I'm going to start off with number 1. Angle 1 is congruent to angle 4 because they gave that to me. And since angle 1 is congruent to angle 4, I'm going to mark it in the picture, but those are alternate interior angles on line L and N. So I could say for number 2, L must be parallel to N because of the converse of alternate interior angles theorem. Again, I'm proving lines are parallel there, so use a converse. Then I'll go on to my second piece of given information, which is that angle 3 and angle 4 are supplementary. Of course, that was given to us. Now, if angle 3 and angle 4 are supplementary, I know that M and N must be parallel. And that would be your converse of same side interior angles theorem. So again, I didn't know they were parallel, but if the same side interior angles are supplementary, they must be parallel. And now I'm going to use my transitive property that I just talked about. We had L is parallel to N. We had M is parallel to N. They're both parallel to N, meaning L and M must be parallel. And that's going to be your transitive property of parallel lines. So it's the same lesson as yesterday, just in reverse. Starting to use some converse. We did add transitive property of parallel lines, but ultimately it's pretty much the exact same lesson, just in reverse. So try your homework, bring any questions you have tomorrow.